Welcome back. We're going to finish up our discussion on Chapter 1, Section 6 today. In the last video, we talked about how to solve compound inequalities, both and or. And so in this video, we're going to finish up by also incorporating absolute values into the mix. So we're going to discuss compound inequalities with absolute values, how those things tie together, and if you stick with me and take good notes, I think you'll learn this stuff and you'll have it in the next, 20 minutes or so. Let's start. Our first example here is example 3a. You can see it right here in the notes. We want to solve the absolute value of d is less than 2. So we're finally putting together absolute values and inequalities. And we want to graph that solution set on number line. All right. Now, if the absolute value bars weren't here, this would be a really easy problem. There wouldn't be anything to do. D is less than 2, we'd be done. But since that is the absolute value of D, there is a little bit more going on here. So in order to solve that, I want you to think about a number that you can plug in for D such that the absolute value of that number is less than 2. Can you think of a value for D that you could plug in there that would make that work? I can think of one. 1. If we plug in 1 for D here, we would have the absolute value of 1, which is just 1, right? And 1 is less than 2. So if we plug in the number 1, this is true. So the number 1 is one of the solutions. Turns out there are a lot more, though. Another number we can plug in that would work here. A number that has a small absolute value. How about 0? The absolute value of 0 is just 0. And 0 is less than 2. So 0 also works. Are there any other ones? Could D be a negative number and this still work? If positive 1 works, what about negative 1? What is the absolute value of negative 1? It's positive 1, right? Remember, those absolute value bars take anything that's inside and make them positive. So, again, 1 is less than 2. So, negative 1 also works for D. So these are 3 of the numbers that work. It turns out, any number you plug in here that is between 2 and negative 2 works. So we can go straight from this to this. We can go straight from what we started with to this. This is saying D can be any number between negative 2 and positive 2. And it turns out, to solve something like this, it doesn't matter what's inside the absolute values. The thing that's inside is what goes in the middle. And then whatever this value is, it goes on one side. If it's positive, it'll go on the right. If it's negative, it'll go on the left. And the opposite of that number goes on the other side. So since we have positive 2 here, this becomes negative 2. What you'll see in the last example is if there's something a little more complicated in here than just a letter, you might have to solve a little bit more once you get to this point. But for this problem, we're done. Well, I shouldn't say that. I really shouldn't say that. Because look what it says right here. Let's graph this on a number line. This is just like the and compound inequalities from the last video. If we know D is between negative 2 and positive 2, then to put this on a number line, We should probably put the numbers -2 and +2 in there. Circles. Are we going to close these circles or keep them open? We keep them open because these are just less than signs, no or equal tos. And since the D is in between the two values, we're going to shade in between. So there's our number line. Okay. So if this is a less than sign, if you have the absolute value of something is less than something else, that's going to turn into this. Okay. So let's see what happens if this is a greater than sign or a greater than or equal to instead. So, example 3b. Now we want to solve the absolute value of D is greater than or equal to 2. So, let's do the same thing, and let's think of numbers we can plug in for D such that the absolute value is at least 2. 2 or bigger. What's a number that could work there? Well, we could put a ginormous number in for D, like 1,000,000. Because the absolute value of 1,000,000 is going to be bigger than or equal to 2, for sure. Okay, so like 1,000,000 works. Okay, so 1,000,000 is one of the numbers that works. Let's think a little smaller. What about 3? What's the absolute value of 3? Just 3. Is 3 greater than or equal to 2? Yeah. Yes, it is. So 3 is also a number that works. So you might start getting the idea, any number that's bigger than 2 works. What about 2? What about exactly 2? The absolute value of 2 is just 2. And is 2 greater than or equal to 2? It is. 2 is equal to 2. So 2 does work here. If we tried to plug in 2 for this one, 2 is not less than 2. So it all depends on whether that's an equal to or not. Since this is an or equal to, 2 does work. So is it just the numbers bigger than 2? What if the number's like really big but negative? What about like, well, let's start with smaller negative numbers. If 3 works, what about -3? This is 3, right? And we already said 3 is greater than or equal to 2. So -3 works. So that means numbers that are bigger than 2 but negative work. What about -2? -2? The absolute value is just 2. And again, 2 is greater than or equal to 2. Okay? So this time, if we put a really small number like 1 or 0 in here, it's not going to work. It's the numbers that are really big or really big but negative that work. So if we start with this, if this is a greater than or equal to sign, this actually turns into an or compound inequality. We've got D is greater than or equal to 2, or D is less than or equal to -2. Okay. So if we have an absolute value with a less than or equal to sign, it becomes an and it looks like this. If we have an absolute value with a greater than or equal to, it becomes an or, and yet split into 2 pieces. To graph this on a number line, You got -2 and +2 there. Circles on both. Do we fill in those circles? This time we do, because these are or equal to's. So fill in those circles. Now, we're doing both of these on the same line. We're trying to make this a little quicker than when we did the separate lines and then put them together. Let's start with this one. If it's greater than or equal to 2, that means we're starting at 2, this circle, and going in which direction to shade. That's pointing to the right. So we shade this way. And then for this one, starting at -2, less than or equal to, that way, to the left. So we're actually shading to the outsides for this one. So and we shade in between. For or, we shade to the outsides. Now, that was a really quick introduction. So you might still be a little fuzzy on how these worked. That's okay. There's still one more example here. If you feel confident that you can do this, go ahead and try this last example on your own. You can pause the video, come back if you get stuck, or you see if you can get an answer, and we'll see if it's right. What is the solution to the absolute value of 3x minus 3 is greater than 9? Okay, so we've got something inside these absolute values, and we've got a greater than sign. So right off the top, you know it's going to be more like this example. Because this was a greater than or equal to, this is a greater than. Okay? It's going to look something like this. You have to break it into those two pieces. So let's try that out. What are those pieces going to look like? Well, if we've got this, then if we want this first piece, it looks like we just write what's here, but without the absolute value bars. So that's just 3x minus 3 is greater than 9. Cool. For the second piece, it looks like we still just write what's inside the absolute values, which is 3x minus 3. But the sign flips. So this is going to become a less than sign. And the 2 became -2. We put the opposite sign on this. So instead of 9, we're going to put -9. Okay. So if you remember when we first talked about solving absolute value equations, this is kind of like case 1 and case 2. Back then, when these were equal signs, case 1 and case 2 both had equal signs. What changed is that these had opposite signs. It's the same thing here. We're still using the same idea. Nothing has changed. Okay, but since we've got an inequality symbol here, case 1 and case 2, the signs have to flip as well. So we change the sign of this, and we flip the inequality symbol. Just like when we solved absolute value equations, we have to solve both of these for x now. It's not as simple as this. Here the d was already by itself. We got to get the x by itself here. But I think you can do that. This might be a good place to pause if you got stuck and go from here. See if you can get the x by itself and see what you get. All right, here we go. We're going to add 3 to both sides. So we have 3x is greater than 12. Divide by 3. X is greater than 4. X is greater than 4. Second one here should be the same 2 steps. Add 3. 3x is less than. This time we have -9 plus 3. So if you think of a number line, just in your mind, Negative 9 is going to be down here because it's negative. But if you're adding 3, you're bringing it closer to 0. So that's negative 6. Divide by 3. X is less than negative 2. Now you might be like, Mr. C, you didn't flip your sign from here to here. This is a negative 6. This is a negative 2. Those are negative numbers. You should flip the sign. You only flip this sign if the number you divide by is negative. Since we divided by a positive 3, this sign stays the same. But if you were thinking that, it shows that you are really immersed in this, and that is a good thing. So, we've got our two inequalities, just like we did here. We now need to graph it on a number line. So we've got two numbers here. We've got negative 2 and 4. Let's put circles. We're not going to fill those circles, are we? No or equal to signs here. Now we take these one at a time. Starting at 4, this is telling us to shade to the right. So we start at 4, shade right. From negative 2, we shade left. And once we knew that negative 2 and 4 were the numbers, we knew that this was an or because this was a greater than sign. So we should have known that it was going to be shaded to the outsides. But it's good each time to think about it. Okay? This is to the right of 4 and to the left of negative 2. So there it is. All right. So that is all the examples from this section. We talked about compound inequalities in the last video. And here we incorporated absolute values into inequalities, and we saw how those worked. So, there will be some problems for you to work through on Canvas. If you have questions about those, feel free to shoot me an email. I'd be more than happy to work through a problem with you that's on the homework. That's perfectly okay. I will do that for you. It's almost like cheating. But hey, I'm allowed. I can do it. So let me know if you have any questions as you work through those problems. This is also the last section in Chapter 1. So, there will be a test over the Chapter 1 material, but any notes that you've taken so far, any notes you have, you can use those on the test. If you want to have your Chromebook open to these lecture videos and look at those while you take the test, you're allowed to do that too. It's fair game. So, there will be a review that is on Canvas that you can work through. And I'll provide the key for that as well, so you can see how those problems work. Those problems will be very similar to the test. So one of the best things you can do to study for the test is to look for that review in tomorrow's lesson. Go through those problems, see what you understand, see what you don't. Ask questions if there are things you don't understand. And then by the time the test comes around, you'll have a great study guide to work through as you see those problems. So that is my recommendation to you. Use your notes, look through the review, and you'll be ready for the test. Let me know if you have any questions. Good luck on the test. We'll see you in the next chapter.